And it's a great pleasure this afternoon to welcome also Chris Greer, who is the project director for FlyZero. And it's particularly good to see that we have such a large and international audience, so you're all very welcome. We aim to listen to Chris and then have some questions, discussion, etc. So it'd be really good if you were to post your questions as we went along. The whole business of climate change is very much in focus at the moment, and FlyZero is one of those manifestations, of which more in a moment. But a little about Chris, our speaker. He's got a wealth of experience in the aerospace business, particularly on major strategic projects, and often with a flavor of disruptive and novel technologies about them. And he began his career as a graduate apprentice with Doughty, and then subsequently, a little further down the line, became a long service GKN executive, having been both chief engineer and chief technology officer. His experience covers many of the facets that the FlyZero program scoops up, from design and research to manufacturing process development, operational costs, product strategies, and of course, airworthiness. He's well equipped for that, not only through his industrial experience, but his academic experience. He's got a master's in aircraft design from Cranfield. He's a fellow of the Royal Aeronautical Society, of course, and a visiting professor at Bath University and with the Royal Academy of Engineering. Now, the climate change challenge is very real, and it is a real challenge. There has been a lot of international focus of late, and in particularly as we are here on the eve of the G7 meeting. But COP26 in Glasgow, hosted jointly by the UK and Italy, is going to be a significant milestone in the global attempt at controlling climate change. And here in the UK, even with the 6th carbon budget about to be enshrined in law in this session of Parliament, and that's a really challenging set of targets to be met by 2035. And the reason for that is it's got to be done, otherwise we will find ourselves pushing up against 2050 with an unconquerable target. So all that's been focusing industrial minds for sure: electrification, synthetic aviation fuels, and in spite of the impact, the economic impact of COVID-19, there is still significant investment and focus amongst both the original equipment manufacturers, the OEMs in aerospace, but also the airlines, and that's obviously a very good sign. But FlyZero is more than just an incremental addition, and I think there's two reasons behind this. The first reason is that it's led by the Aerospace Technology Institute, the ATI, which is independent and backed with government funds. And secondly, it's aimed at producing the design of a zero carbon aircraft by 2030, a significant challenge. But who better to tell us how to meet that challenge but the project director himself? So over to you, Chris.
Thank you, Sir Brian, and good afternoon to everyone who's on the webinar. I'm going to take you through what we're doing in FlyZero and hopefully show you the sort of things that FlyZero has produced in what is a very short time. So let me just put on the screen. So hopefully you can see my screen. And what I would like to talk to you about is, well, what is FlyZero? As Sir Brian said, it's sponsored by the UK government, but it's backed by the Aerospace Technology Institute. And we're focused on how we can develop zero carbon emission aircraft and how we can do that in a rapid time based on where the capabilities need to get to support what's happening in the industry and what's happening in our global environment. So I'm going to take you through 3 slides just showing you what we're doing within FlyZero. So in FlyZero today, if you look at what is the carbon challenge for aviation, so today 885 million tons of global CO2 emissions from aviation goes each year into the atmosphere. Now this is based on 2018-2019 study, so it's obviously not impacted by COVID, which would see that number come down, but still it gives you a feel for how much carbon aviation in its own right is putting into the atmosphere. That represents 38.3 million commercial flights in 2019 and moving 4.5 billion people, so incredible number of people. But when you bring it down to somewhere in the UK like Heathrow and just take a typical day in Heathrow's operation, it actually has to deliver into the airplanes that fly out of Heathrow 22 million litres of kerosene. So you can get a feel for the scale and the volume of fuels being used in these aircraft. And this is an important point because I will come back to it when we talk about how do you get to zero carbon based on these numbers. There's a second potential impact from the operation of aircraft, which is around contrails. And we've concluded with the help of various companies in the UK that that impact can be as big as 1.5% in terms of creating contrails and capturing CO2 into the atmosphere. So another area that needs addressing. But overall, our target is zero. So we've got to get from where we are today, 885 million, to zero. And that is clearly an immense target for any group of people to do. But I have to say, I have an amazing team working on FlyZero, and we've only been going for 5 months, but we're really beginning to discover some of the technology that's needed out there to help protect our planet and help us meet our carbon commitments for aviation, because we must radically reduce the greenhouse gas emissions that we're doing. So Brian said the FlyZero project will identify those future technologies and opportunities for the UK to develop a new generation of zero carbon emission aircraft. And really our goal is to realise zero carbon emission commercial flight by the end of the decade. That's what the government set us to do. That is a big challenge. But the reality is the time is right. We need to act now because we are in a race to create the next generation of zero carbon emission aircraft and secure a share of the economic benefits this will bring. The sooner we develop zero carbon technologies, the sooner we'll enjoy the benefits both environmentally and economically. So this is a major opportunity for engineering in all corners of the UK. And FlyZero will help the UK stand at the forefront of sustainable aviation in design, manufacturing, technology development, and most importantly, skills within our existing teams. We are all working from home and we're all working in the COVID restrictions that we now face today. But they have been brilliant at creating ideas and solutions that support the challenge that we're after. So let's talk about our ecosystem. And really, we're taking a holistic approach to it. So not only are we looking at the aircraft, we're investigating the best zero carbon emission energy storage and propulsion. We're looking at mapping the UK industrial capability and identifying the manufacturing demands for tomorrow, as well as understanding the UK supply chain, trying to define some of the operational requirements and capabilities of future aircraft, assessing that sustainability credentials of future aircraft, and really looking at regulations. And we have recently signed an agreement with the CAA to support us on regulations and policies around zero carbon emissions. We're also analysing the market and the commercial and economic aspects of the market so that we can make sure that the aircraft we're proposing do actually fit within the constraints of what may be the future market. And we're partnering with a lot of the UK academics, so universities, research centres, and industrialists to help us develop some of the technologies, or technobricks as we call them, that are needed to produce carbon emission aircraft. We do have a plan, and this is very much a high-level plan, where we're actually now reached a phase that we call phase 3, where we're starting to look at our scouts. We have a group of scouts, which I'll show you a few later, which are aircraft that meet the requirements of zero emission, but they have different ranges, different payloads, different configurations, and we're assessing each of those on an individual basis against the criteria that we've generated over phase 1 and phase 2. We're working very much, as I say, from home, so we're using agile methods in terms of how to develop solutions, and we're looking at how we can bring those challenges to the team so the team can work in small groups to actually solve challenges and then relay that back to the rest of the team. So in doing that, we've also got our streams, which are looking at sustainability, our commercial strategy, our industrial strategy, academic research, and then at the bottom there, the technical engineering, which is back to our sort of key challenges that we're running. So you can see we've got a timeline where we're planning to complete the whole project by the end of February, and we have outputs that we need to give to COP26, to the government, one of our shareholders clearly, and also to the stakeholders. And that's the way we're operating. So we've looked at the market sector, and we've identified that in the wide body operation, which represents about 9% of global flights and about 45% of available seat kilometers, it does represent 52% of all CO2 global emissions. And that's including freighter, which is around 19% of that 52%. The global short-haul market and regional operations represents 91% of flights and 55% of the available seat kilometers, but it represents 48% of CO2 globally. So from our simple analysis here, there is a split of almost 50-50 between twin aisle and single aisle operation. And we're going to look at identifying and working on the single aisle areas, which we think are very applicable today for some of the zero carbon emission equipment that we're discussing. One of the key topics, though, is sustainability. And I've already mentioned to you that the amount of global carbon emissions is 885 million tons. Well, the UK equivalent of that is 37 million tons. And this represents about 2% of the global emissions of carbon. So we're working quite hard with the authorities in terms of ITAR and ACARA and the UK Sustainability Aviation Group to identify how we can get down to a 50% net carbon reduction. So part of what we've been doing is trying to set some emission targets that we think are important to achieve. Now, the Paris Agreement was to get down the temperature rise from 2% per year to 1.5 degrees by 2100. The net zero greenhouse emissions, CO2, by 2050, which is the agreement that was struck a few years ago, actually the UK policy that was just released reduces that CO2 by 78% by 2035. So again, the UK government is challenging some of the agreements. So what we see is the science is clear. There's more extreme weather occurring around the globe due to global warming, which is impacting not only us as people, but also our food supplies and the way the world is working. So we're trying to set some emission targets here, which talk about CO2 being at zero, NOx 25% lower, particle matters down by 50%, and also noise reduction by a 7 dB. As well as that, we're looking at water because we're trying to assess the contrail avoidance of how we can get around that of water. If we can do those things and run that through our full life cycle analysis approach using different energy sources, as you can see there, then we're trying to create the model that you see down in the bottom right-hand corner to determine the environmental impacts from our different models. We've done a very rough calculation that says we think we could save 2 gigatons of CO2 by 2050 if we can put some of these things in place over the near term. So that's part of what we're doing from a sustainability point of view. And what we've also identified is that 80% of the aviation emissions that we're really dealing with come from the operation of the aircraft as opposed to the production of the aircraft. So at the moment, with the systems that we fly today, the majority of that CO2 emissions is coming from operations. So the choice of fuel becomes fundamental. And this is one of the sort of key issues that we're focused on. So let's just talk about what is FlyZero's mission and where does it sit. So on this axis, you can see the years at the bottom, and vertically, you can see the nautical mile range of various aircraft. At the bottom there, you can see the electric VTOL aircraft, which are principally all electric, and we're not going to do any research within the FlyZero team on fully battery operated aircraft. At the very top there, you can see the twin aisle aircraft, which are all very new. They're a heavy investment in these aircraft and their engines. And the validation of sustainable aviation fuels is key for them. So we see that as an area which we won't do any research in, but we are keeping a close eye on and ensuring that we understand what the findings are from the sustainable aviation fuels in this market. Where FlyZero is studying, though, is the alternative energy propulsion systems aircraft, and looking at that fuels and equipment and the architecture and configuration and the regulations and certifications and the sustainability of those products. So as you can see there has been announcements over the last couple of years from Airbus with Zero-E, from the US and NASA, and also other programs around hybrid and that. So those are the areas that we're looking at. And part of our initial findings on the primary energy source is indicating that these are some of the choices that we will have to make. So we can see that in the regional aircraft, batteries just will not have enough energy density against mass to support us. We also see that with the gaseous hydrogen. We're still working on the fuel cells, and we're looking at hybrids, which is a combination of several different energy sources. We think as a primary energy source, ammonia, because of its toxicity, will not be a viable option. And the key front runner at the moment we are finding is called liquid hydrogen, which brings with it lots of other complications, which I'll come on to. But hopefully you get a feel for what FlyZero is focused and where it's driving to. So what have we been doing from a timeline? So on the left here, we have created a load of what we call technology brick developments. Each of those technology bricks is something that we're focused on and developing to make sure that we can see how it could be used in a zero carbon emissions aircraft. And it will be a combination maybe of those bricks that would end up in those aircraft, or it may be one on its own right, part of the work we're doing. Our objective is, though, to get by the middle of this year to two scenarios. One is creating a load of technology roadmaps based on these technology bricks, which show what work needs to be done on them to develop them to a mature level. Looking at the economics of those technology bricks as to how they could be taken into commercial revenue, and assessing the sustainability of each of those bricks. So that's one activity that we will be providing back to the government, those roadmaps. And that will also include the industrial capability roadmap to show if we've developed a new technology brick, where might be that capability in the UK. We will also take what we call our scouts and develop 2, maybe 3 aircraft concept developments, which will take those to the next level of analysis to try and work out what are the key components in them and what would there be truly performance available to you. Now, FlyZero has a program timescale that would, at the moment, run out at the end of February 22. But we are very much focused on what would the next steps be. I think I've got a highly motivated team with a lot of technical capability, and it would be very worthwhile for us to carry on and help support the industry in the UK to manufacture some of this hardware and test, validate, and certify it to a standard where it's run on a ground rig. We would like to take it even further and install some of that kit on an existing airframe and run some sort of experimental flights in the UK or in the global aviation world to look at how you validate those regulations and performance. And on the technology bricks, is sort of offer that technology to the global aircraft OEMs as future items that they could use on their aircraft. So we're really focused on several areas where we think FlyZero could provide further support and development of these concepts in the future. There are 3 propulsion systems that we're focused on that are all potential. One of them is a hybrid hydrogen combustion, the other is a hydrogen fuel cell, and the third one is a battery electric, which, as I've already indicated, doesn't show some of the performance requirements that we're looking for across the range of vehicles. But those are some of the technology bricks and how we're using them as an example. When we get down to the fuels though, we have done a study now looking at battery, liquid hydrogen fuel cell, liquid hydrogen combustion, gaseous hydrogen, ammonia, and we've also compared that against sustainable aviation fuels. And what we tried to do is look at what the CO2 emission is, the NOx emission, the contrails, the fuel volume, the fuel system mass, the energy density efficiency, and the airport infrastructure. And as you can see, all of them require levels of technical input as well as investment to bring them to the market so they could be used in a commercial aircraft. At the moment, our studies indicate to get to a zero carbon emission aircraft, you really need to focus on liquid hydrogen as a combustion. And that is one of the areas that we're working on, but we recognize that creates quite a bit of new aircraft infrastructure and new airport infrastructure. So that's our focus. And we also recognize that SAF is a stepping stone to getting to zero carbon emission, but it doesn't get you there because of the potential in terms of CO2 emissions and NOx emissions. So as I said, we've been creating scouts, and just to show you as an illustration some of our scouts, this is 2 of them, or 4 of them, I should say, that we're looking at. And each of these has a reason for being like it is in terms of configuration and shape. But all of them are performing a duty, which is zero carbon emissions. And we will continue to develop our scouts. And these are purely for an illustration of the creativity and talent in my team, but not final solutions. And we will work on those over the coming months. So when we say all that, there are additional challenges we have to face. So operations, I mean, as I've described to you, if we go to a liquid hydrogen solution, that means significant changes for the airlines, the airports, and also we feel for the airspace, including the means of dealing with contrails, but also the production, supply, and distribution of the fuels. So lots of new methods and skills required, and probably lots of reskilling of people and equipment developed to actually allow that to be operational. On the supply chain, we can see that we are looking in areas like the fuel cells, the hydrogen storage, cryogenics, hydrogen combustion. And if we are to compete, we need to develop our areas in the UK very quickly, or look at how we can collaborate with the efforts going on in France and Germany, but to build the strength within the supply chain to provide this equipment to aviation. On sustainability, even the zero carbon aircraft could have a climate warming impact through contrail formation and atmospheric chemistry. So we are working with leading climate scientists and universities to understand and minimize these impacts. And part of our report out will describe how we're dealing with that and what do we think are the fundamentals that we need to work on. And then finally, policies and regulations. Like any new vehicle, there's a large criteria of new certification and regulations needed. And the next generation of zero carbon emission aircraft technologies and their safe operation are going to really require a much bigger team than FlyZero to validate and regulate how they get taken into a commercial environment. And that's why we've teamed up with the CAA to help us at least get that limited knowledge of understanding before we move on to the next factor. So what are the next steps for FlyZero? So the Aerospace Technology Institute is seeking further investment as part of the government's comprehensive spending review to support technology and innovation in the industry. And that, we hope, will deliver on our net zero targets, including the zero carbon emission aircraft. And in doing so, the aerospace sector can boost growth and raise skill levels across the country, accelerate our strategic technologies, and firmly position the UK as a science and engineering powerhouse. And this is very much something that is focused within the FlyZero organization. We recognize that we are dealing with some science and some engineering, which we have limited capability within aerospace, but is vitally important to actually minimize and even eliminate carbon emissions. So I think it's in all our best interest to look at how we can develop not only the people capability, but the industrial capability within the UK and within the manufacturing sectors to support the way forward. There are still opportunities to be part of FlyZero. We are still on our webpage putting out work packages and inviting organizations of all sizes from across the UK with specialist expertise to tender for some subcontracting opportunities across a range of areas, including energy storage, propulsion systems, airframe design, integration, commercial, industry, and sustainability. We are still very much trying to develop some of the answers to the questions we're forming. So please look at our website, and if you are interested, please apply. We are also running some forums and workshops and some other events, such as this webinar, to make sure that we're reaching out to the public to let them know what we're trying to do, but also ensuring that if we have any stakeholders out there who feel they can help and lead us, direct us in terms of priorities for future activities, we're very much interested in that. So we're not a closed house in any way at all. So in conclusion, the challenge is clear. To protect our planet and for the UK to meet its carbon commitments, aviation must radically reduce its greenhouse gas emission. The time to act is now. We're in a race to create the next generation of zero carbon emission aircraft and secure a share of the economic benefits this will bring. The sooner we develop zero carbon technologies, the sooner we enjoy their benefits, both environmentally and economically. This is a major opportunity for engineering in all corners of the UK, and FlyZero will help the UK stand at that forefront of sustainable aviation in design, manufacturing, technology, and also skills development. And the UK needs to develop both the net zero and the zero carbon solutions to future-proof our aerospace sector and maximize the positive impact we can have in the fight against climate change. And finally, thank you to Sir Brian and the Royal Aeronautical Society events team and you in the audience for your support to FlyZero so far. I look forward to working with you in the coming months. Thank you.
Well, thank you very much, Chris. That's you've covered a lot of ground there, but a very impressive agenda that you've been set and that you're developing. It won't surprise you, there's a lot of questions. There's a distinct theme about propulsion and alternative methodologies, etc. But where I'd like to start is just on the regulatory aspects and just have a look at some of the international impacts of those after that. But in terms of the regulatory challenge, now we've just lived through a decade where the complexity to apply the current regulatory framework for certification to drones and in the urban air mobility area has proved very difficult. Now, are we looking in this case, are we looking at more the way in which FlyZero will produce an airplane which is broadly going to fit into the current regulatory environment, or is this completely new? Yes, of course, there's differences in fuel and the safety case around fuels, but what's the complexity like as seen through the eyes of a regulator?
I think there is some major complexity in the systems that we're proposing, because not only do you have probably a cryogenic tank on board, you've got pipe work and plumbing to get that fuel and convert it to gaseous to get it into the engine, so incredibly complex. And you've got all the issues with how do you fill an aircraft up at a runway with a hydrogen system. I don't think there are any simple answers. I think the airframe structure to some extent would stay similar in terms of regulatory authorities, but all the crash conditions and all the operational conditions will be seriously affected.
And overlaying that complexity, the sine qua non in aerospace is that we have unified certification standards across the globe where possible. So how do you see the international side of that either being harmonized or catching up or whatever?
I think that's a really good question. I can see that we will set a set of technical criteria where we will need to harmonize it across various authorities, airworthiness authorities, and we will need to probably form a forum where we could actually support the debate about what are the key things around the certification of these type of fuels and these type of vehicles compared to the regulations now. So hopefully the standard flight conditions would stay the same, but I think a lot of the, as I say, operational regulations would definitely change. The handleability of the fuels and that will definitely change. And I suspect a lot of the testing requirements could change. And the only way I can see that happening is aviation is a global world. We need to do it in a global approach. So we would need to look at how these changes would impact certain areas of the regs, but also how could we join in a global aviation community to solve that. So I very much would look at the CAA helping us, but we will definitely need EASA and FAA to be part of that.
And yeah, that's interesting because this global community, presumably there are aspects of it starting now. For example, Horizon 2020 funded the Clean Sky 2, the joint undertaking, etc. Have you yet got tentacles into any international programs?
No, not today, but we certainly recognize that's part of what the next step for FlyZero would be, is how do we then take what we've found and developed and then bring that into more of the global aviation organizations. So we're very much centralized in terms of we're focused on what is the ability within the UK to develop these systems and create solutions. But we fully recognise that the future lies in engagement with the bigger communities.
So let's now switch to fuels, propulsion, etc. And whenever we shine a light on this area, it, in a sense, becomes controversial in terms of who owns the problem. And got a question here now which says, well, isn't this the cart before the horse? In other words, to what extent is it the responsibility of the energy producers, i.e. the Shells and BPs of this world, to accelerate their development of sustainable aviation fuels and ultimately cryogenic hydrogen? But first off, have you got any of the energy producers in your industrial cohort?
We are speaking to them about what we think is the criteria, but I think the bigger risk we run here, whether it's sustainable aviation fuel or a hydrogen fuel, is actually the manufacturing capability of those companies at the moment to make those fuels is limited. So when I talked earlier about the 22 million gallons of fuel Heathrow used in one day, well, that's 88 million gallons of hydrogen, for example. Well, actually, we don't have that capability anywhere in the world, as far as I know. to make those sort of volumes. Now, I'm probably wrong there because I don't know the world as well as I should do on this fact, but I know that sustainable aviation fuel, because we've spoken to a few people on that, is principally made in the US. They're hoping to get to 1 billion litres, I think, by 2025, and maybe 1 billion gallons by 2030. So I think sustainable aviation fuel at the moment, the plan is by 2030 to use about 10% of that in the fuel. So I think one of the big risks here is the industrialization of the, as you say, the cart before the horse. We need some infrastructure in place to allow these things to happen.
Yeah, and I think, I mean, the more we talk to people about this, there is something about building up investment and investors' confidence. And it's always good to see big companies with big, strong balance sheets coming around the table. And that's not only manufacturers, that has to be the Shells and BPs and all the international versions of them. Just in terms of what is over the horizon, which is still perhaps nascent technology on the bench of a university somewhere, are there any radical non-combustion based propulsion technologies out there that are stimulating your imagination? I mean, people talk about photonics in this area now. It strikes me as a physicist that's a long way off, but you know, what are you looking at out there well beyond your 2030 horizon?
I think that's an area where we haven't had enough time to come up with some of those sort of scenarios. So we've looked at what we can see that is closer to us in terms of our experiences, and this might be a gap within the community that we're working in. So it's something that we will continue to do. I just showed you a snapshot of the fuels that we've so far looked at, and we're clearly looking at hydrogen and we're looking at ammonia. But we need to do more. So again, there's just a lot out there to do at the moment. So it's on the list.
It seems unfair to probe you on something like that, but one of the areas that you've clearly come to a conclusion on is the prospects for future development of battery technology at the sort of power densities that we need in aviation. But you know, is there a sense that there is some new chemistry around the corner? I mean, we've been looking at sodium ions for some time, but you've, how can I put this? You seemingly have dismissed battery technology.
We've done some energy calculations against mass, and we've tried to look at 500 kilowatts per hour type battery sizing. And for a sort of regional aircraft, we're not finding that we could run that aircraft on batteries alone. So I'm not dismissing batteries as a technology we might have as a technology brick on an aircraft, but it's not a primary energy source is where I'm at the moment. So we are talking to battery specialists to find out what, if any, other options are out there for batteries. But at this moment in time, the one I've mentioned, the 500 kilowatt per hour, is actually outside where batteries are today. Yeah. So even that is 2030 technology. Clearly we're looking at it. We're talking to industrialists and academics about what might be there. But today it's probably good for what it's doing on the eVTOL side of it. But when you get to something that's heavier with a payload and a range of say 500 to 750 nautical miles, it's a struggle, and therefore you're not going to get the economics to work.
Related to that, I mean, one of the things that interests us in the society, you know, we've got a greener by design specialist group that's been going for more than 20 years, looking at carbon and non-carbon, but increasingly we're being challenged to look at the end-to-end aspects of emissions, of impacts, etc. So, I mean, in one of your diagrams, you pointed out that you can, if you like, propose a drop in fuel, but it still makes a big difference to the infrastructure, and hydrogen will be one of those. But how far into the entire carbon budget for, if you like, a single passenger on a single seat, end to end, are you likely to go?
We've actually had a discussion this week about trying to predict for the different energy sources per seat mile, should we say, how much carbon it's costing us, so that we could actually do some comparisons along the line that you've just spoken about. So that is some of the challenge work that we're running in phase 3. We do want to understand what is the amount of carbon that goes into manufacturing the aircraft, and we've got some work going on that so that we can see that. But we initially have worked out that the operational side, as I said, it seems to take 80% of the carbon emissions into the atmosphere. So it's definitely on our list. And we, as you can see, we have a few airlines. EasyJet is one of those who's supporting us, and we've also got NATS supporting us as well. So it's work that we will do.
Yeah, I mean, one of our attendees is pointing out that when we come to cryogenic fuels, the fuel hose from the hydrant on the pan looks entirely different. It's solid and obviously has to have thermal properties, etc. So this is essentially quite a big end-to-end change for something that people probably think is, when they think about domestic boilers and the use of hydrogen, they just think it's a drop in fuel. You're quite right there. Yeah. Touching on skills, and you showed that as an element of one of your graphics. What areas do you see that we are deficient in skills in the aerospace sector in order to meet this challenge? It's something that we wrestle with in the society continually.
I've got a very multifunctional team, highly skilled, but what I'm finding is that, you know, some of the specialist areas around hydrogen and cryogenics and tank storage of hydrogen and, you know, the refueling side that you've just described are very limited knowledge within the aviation community. So there's almost a need to reskill probably people who are out there already, or to reskill some of the aviation people to understand that. We have a tremendous capability in the UK on fuels, you know, within the Airbus community. So I can see them maybe wanting to do some reskilling. There's also a challenge about what's the best way to refuel a plane in hydrogen. Is that to refuel it with a hose, or is that to provide it with a tank that's already full and just connected into the aircraft? So all those things my team are looking at as well, because we're running a pilot for them to try and identify how do you manage an aircraft where the turnaround times need to be 25 minutes. So yeah, we're challenging ourselves on lots of different paradigms to see what the issues are. Because if in the end of this process we haven't been able to answer all the questions, what I'm insisting my team does is we generate all the questions. If we don't know the answer, we'll at least have the question that we need to get answered.
And what are you finding about the level and availability of skills in electrification, for example?
Yeah, so that's another area where electrification, there is a limited knowledge of the electrification side and also the system side, the integration of the system. So, you know, those are two areas that we definitely need some more capability. Maybe it's been underdeveloped in the aerospace communities, but it's certainly a gap. And I think the other gap which we're working on is the whole aircraft modeling aspect. Because if you could imagine, we've taken a plane and we've moved all its masses into different locations around the aircraft, and then we're trying to say, is this going to fly? It's a challenge. So actually having that capability, and we do have a couple of very good people who are doing that for us, is a challenge, and maybe that's another area the UK needs to further enhance.
And related to what you just said, in terms of modelling the climate impacts of potential designs, etc., how is that being done? Is that in-house, or is it my friends at the University of Reading, or?
Yeah, we're using two different universities who have models on sustainable impacts to help us here. So we've, again, as I was saying earlier, we have put out statements of work, and they bid on them, and they went through a process of being awarded them, and they're actually working on those now. So those are things that we've actually put out into the community. So because we recognize we don't know everything within the limited team we have. So and including things like combustion of liquid hydrogen. We're not the specialists, so but we've identified that's an action. So we've actually put that out as well as an activity. So we are using the network within the UK to help us find some of those answers or give us some of those questions.
And it's telling that in your analysis of short range UAM up to wide body long haul, you settled on single aisle aircraft. And it's very interesting that in the last, 4 weeks, Airbus have said they're going to up the production on the 320 XLR. Boeing have said they'll do a 737-10 stretched a couple of meters, because the impact of COVID and recovery from it is showing that's the sweet spot. So how do you see the reality, or how do you see what you propose becoming a reality as a public service aircraft?
Yeah, that is a really good question. So there's several views here, because as you know, France and Germany have put a note out saying if you want to fly locally, i.e. in country, and it's less than 2.5 hours, you need to take the train, not a plane.
Yeah.
So I see a resurgent possibly of what I'll call as a regional aircraft. A regional aircraft is a slightly lower risk in terms of development and bringing into production. It's still expensive, don't get me wrong, and it still requires a lot of authority and approvals. But it appears to me that there's a couple of ways of doing this. One is aerospace needs to develop the technology and mature it before it would actually get to a single aisle, because the single aisle is such a massive opportunity or cash cow, call it what you want, for the aviation industry. We can't afford to just sacrifice it. We need to have something that's fully stable before you would change the single aisles. So one of the options we've been debating, but I'm not saying it's the answer, it's just that something we're talking about, is maybe the approach is you take a regional size aircraft and you develop the technology for that, which is based on the technology you might apply into a single aisle, and you mature that and you get that into operation and you determine what all the issues are with that. And then once you've got a network, which might be a UK network, it might be a French network, but it's basically an in-country network, you could then apply that to the next step, which is bringing that into a single aisle scenario. Now, I think that's one option. The other option is you jump into the boiling water and say we're going to change all the single aisles. But I think even if you tried to do that, by the time you could implement that change, as Airbus has suggested, it would be 2035. So you producing 40 aircraft a month till 2035 of single aisle. So those will stay in the community, the fleet, for a good 20 odd years. So the thing that I do recognize is this is going to be a long-term impact in terms of making the change. And what I would say, that's probably why you have to go very hard at it to begin with to even start to impact it, because the growth rate we're looking at is something like 4%, I think, in passenger growth rate. So even if you bring sustainable fuel in, you're still growing the carbon footprint you're putting into the atmosphere.
Yeah.
So it's a real challenge.
And, you mentioned boiling water, but here's at the other end of it, and this is a technical question, which intrigues everybody, because cryogenic hydrogen has to be stored about 107 minus 170, something like that.
Yeah.
So how's that done? How is that going to be done in an aeroplane that flies?
Yeah, well, it's obviously one of the challenges my technical team are working on. Creating a vacuum tank is one of the scenarios that we need to get to. And then how do we keep that at the low temperature? We're going to have some heat exchangers and that. So those are all the things that we're looking at, and part of what we're asking certain industry, gas and oil and people like that, to help us develop those solutions. And really that's what I see as the next phase of FlyZero 2, I'll call it, which is to go and develop that and produce it on a ground-based rig and run it. and determine what are all the issues with it. Because we're writing papers on why this looks right, and we need to validate those papers, and also get the authorities involved as well to say what are the regulation criteria that we need to apply to these. So again, another one of the big challenges that we probably all will face.
And just related to that, in that excursion to, as you said, the wide body fleets actually are quite young, most of them, and airlines aren't minded to change them. And certainly the UK's Committee on Climate Change were clear that synthetic aviation fuels are going to be the answer up to 2050 in their assessment. But how do you see that ultimately we will ever get beyond a hybrid version, in other words, a turbofan aircraft with something like cryogenic hydrogen? Do you think we'll ever get beyond that to pure hydrogen type aircraft for wide bodies?
I honestly don't know the answer to that, Brian. I think we haven't even looked at the wide body because we just recognise where it sits at the moment, and its investment is not something we've addressed. We might pose a different question, which is, what do you think the market future looks like? Is it going to be wide bodies, or is it all going to be single aisles?
Yeah.
Okay.
If I could answer that, I wouldn't be sitting here.
Yeah, neither would I. But it is a question that we're posing ourselves.
I mean, looking at it from the point of view of a chief executive of an airline, I can remember sitting with the CEO of EasyJet, Farnborough 2016, and he said, look, you will go to Paris with 30 of your best friends in an electric aircraft, all electric aircraft by 2030. Now, do you have a similar sort of metric in mind of, is this one step at a time, 600 miles, 50 people, etc.? Is that the way you're viewing it?
A little bit, but actually, when we've been looking at liquid hydrogen, we've realized we could fly a lot further than 3,000 nautical miles, and it might be more efficient. So I think the all electric approach, yes, you're probably saying, look, I'm going to do point to point, and it might be it's a 500-mile range, and therefore you can take 30 people, but the economics might be more expensive, and that's probably one of the sort of development scenarios that need to be developed. But there is an argument that says you could take a single aisle or an aircraft of that size a lot further using liquid hydrogen. Is that the right answer? I don't know. All I know is it takes a lot of energy to get a plane into the air and to fly and to land. And that's probably our biggest challenge, why we just can't use the batteries, because the energy level in a car battery is just nowhere near what we need.
No.
And if we need to get rid of the carbon, and there are challenges obviously when you take the carbon out, because the kerosene is not only used for the fuel, but it's also used to lubricate the engine. It's used to cool the engine. So there's lots of things that are, probably things that we will find that regulation needs to be determined, changes the certification of the plane. And I think that'll be the same whether it's a kerosene or if you switch to sustainable aviation fuel, you'll have the same issues. Does it have enough content to oil the engine, or et cetera, et cetera?
Yeah. And just time is catching up with us, but just a final question on the non-carbon impacts. And again, in the society, we've been trying to draw the veil back on the understanding of contrails and NOx, etc., which to a certain extent can be ameliorated by different operating patterns for aircraft. Yeah. But you're looking at it presumably from, as you said, the emissions of water, the emissions of particulate as well, I imagine. Could you just say a bit more about that?
Well, we've set some requirements on particulates that we want to get reduced. If you think by using hydrogen, you will. On the water vapor, we're running a study at the moment to determine, is that going to have an impact, and determine, is there some other way we can utilize it? So I I don't have an answer directly, but it's certainly one of the questions we're working on. So I suppose what I'm really saying to you, there's still a lot of open questions that my team is working on at the moment. So, but that's to be expected because the topic is so big.
Sure, and that's a note to end on in a way, because it's been very good of you to cast your thinking into the future in all these variable directions, which interest this not inconsiderable audience. So thank you very much for your presentation. It's a real eye-opener for most people because, as you say, this is a new program. We've heard a lot about it, and now just to see a lot of detail was hugely interesting. I would say it's immensely ambitious. If you look at the sixth carbon budget as proposed, or which will pass into law, published by the Committee on Climate Change, then your ambition around carbon emissions is considerably more testing than they have set, and they believe that they're being realistic, as it were. And of course, the great work that the ATI does, not only on this, but future flight, is hugely appreciated by everybody in the sector. And we always write in our comprehensive spending review submission that we should double the funding for ATI, and we'll do so again in the 2021 submission, because this is absolutely key. This is what is going to unlock the future in a way that sort of the incremental approach that we've kind of grown used to will simply not be able to do it. So ambition is absolutely important. So you've covered a lot of ground in the few months that the organisation has been stood up. Our congratulations to you and to the team you've got around you, and the best of luck for the future. And to all of you listening, thank you very much for joining us tonight, and do look at our website for future webinars that you might find very interesting. But for now, I wish you all a good evening, and thank you for being with us. Good night.
Thank you very much, Sir Brian, and to everyone who's listened in. Much appreciated.
Good night.